Hello, welcome to my scaled down presentation and recreation of Carl Sagan's cosmic calendar. I'll be walking you through the calendar months, January through December, and discussing cosmic events and highlighting some days throughout the year. The calendar scales down millions of years starting at 4.6 million years ago. In this scaled down calendar, humans will only take up the last few minutes on December 31st, which is all the way down there. I am on the last strip of the mall, right by the softball field and the Eller Studio of Dance. There's a basketball game tonight, so there's a lot of people. There's probably going to be some noise, and there's a little bit of wind, just to preface. But I am here. I have everything lined up and ready to go. So I'm first going to show you my Excel and my bar graph. I have them right here. So here is my Excel sheet. It just goes through all of the events, and I color-coded them. I have green for the months. I have white just for the geological events, and some more white. I have the dates, the billions of years, the day on the calendar would be, such as day 305. The pink is for life forms, blue is for billion year markers, and keep going down. I also have the specific meters apart everything is. And then I also have yellow, those are for the mass extinctions, which starts November 27th, so later on. And I have just one orange, which I put in the pink category, just as life on Earth. And here's my graph. It's a little messy. I'm not sure what happened with the system. I think you can see that okay. I'm not sure what happened with the system, but it has January 1st all the way through December 31st, starting at 4.6 billion years and going all the way to 1 million years and on when astronomers were here, which is my last event. And it's just a time graph. Every single event I have, and I used it. I made it using Excel, which came out somewhat okay, but here we go. So first I have January 1st, the formation of the Earth. It happened 4,600 million years ago, January 1st. Moving on, I'm sorry. This is the formation of the moon, which happened 440 million years ago on January 17th. So yeah, we started 4,600 million years ago. Now we are at 4,400 million years ago. And one of the problems that we had to talk about was what's the most important event in January and February. And I put the formation of the moon happening in January just because it's like it affects our tides, and there's other things that were really important that went into the moon. And so this is also one thing that I want to highlight from the Excel graph. I am highlighting this. When early Earth collided with a Mars-sized object, the moon formed. The moon plays a crucial role in Earth's stability by maintaining the planet's tilt, driving ocean tides, and shielding Earth from asteroid impacts. Without it, Earth's climate and life development would have been dry. And my analogy is that the moon is like scattered water and remnants of a water balloon. So let's say the water balloon hits something. That collision, like the Mars-like object, is the water balloon. It hits Earth, water scatters everywhere. The moon is the water in this analogy. And then that Mars-sized object, speaking of Mars, this is another prompt that I had to answer. What might life on Mars have looked like 3.5 billion years ago? I said likely microbial life similar to early Earth, thriving in water-rich environments. Okay, moving on, we have the crust that begins solidifying. This was 4,300 million years ago on January 25th. And then my prompt that I had to answer was what range of complexity might life on Venus have reached before the oceans evaporated? I said possibly simple microbial life, but nothing super advanced due to Venus's conditions. Next, January 29th, 4,250 million years ago, day 337, impacts deliver simple organics. Okay, and I think that, yeah, now we are going into February, which is 410 million years ago, or day 33 is February 1st. Oh, there's the moon. All right, Oceans fill oceans, February 2nd, 42 million years ago. So that's how far we come from January. We still have a long ways to go. The sun is setting, but there's January. Next, we can walk some more far. The oldest, can you see that okay? The oldest known rock, 4,030 million years ago on February 15th. February 22nd, heavy bombardment ends, 3,950 million years ago. So we are still in February. This is day 313 on the cosmic calendar. Next, we are moving on to March 1st. We are in our new month. Here's my March 1st marker. Formation of the first stable continents 3.8 billion years ago, March 1st. And this is on day 306. And I added this one to the calendar because that is my birthday. Sorry about that. This is March 1st, my birthday, and I wanted to celebrate it. I actually just turned 20 the other day, so I thought why not add it in my cosmic calendar. I chose this because it marks a crucial step in the planet's evolution, the formation of the first stable continents, as solid land provides a foundation for future geological and biological processes. As Earth's molten surface cooled, small islands of lighter rock formed, gradually merging into larger land masses, while mantle heat drove tectonic movements that reshaped and expanded the first continents. In my analogy, I said, like baking a cake, you have all of these liquid things, they go in the oven, and they combine and produce something that is solid, just like this. Okay, March 2nd, 3850 million years ago, March 2nd, earliest evidence of life. I wasn't pointing it out earlier, but you can see like the colors. I marked this one pink because it's life. And I want to talk about this one because I am a physiology major. And so I thought that, medicine major physiology, I thought that the first mark of life is like so cool, and without it, I don't even know what I'd be studying. I wouldn't even be here today. So I said the earliest evidence of life appeared as a single-celled microbes living in extreme environments like deep-sea hydrothermal vents. These organisms laid the foundation for evolution, contributing to Earth's changing atmosphere and provided clues for potential life beyond Earth, like tiny bubbles in a sourdough jar that's fermenting. Life on Earth began quietly. That's my analogy. Okay, and then I want to note March 21st, day 286. That is when the Earth is 1 billion years old. So, and then at that point, at 1 billion years, one of the prompts and questions that we had to add was which kind of life would exist on a 1 billion year old exoplanet. I said likely microbial life similar to early Earth, and a lot of these have just been microbial life because we don't see like a ton of matured or like super ultra developed life forms until way later. So we're gonna keep going. That was March 21st. The next day, the second evidence of life is the oldest fossil. This is dated back to March 29th, day 278, 3,500 million years ago, and these are the stromatolites, so these are just older fossils. And moving on, jumping into April, we have April 1st, day 275, 34,605 million years ago, and then we have April 1st, and like I said, it's going to be several clips. There's a lot of people walking around. There's a lot of people that are fascinated by my project, which, you know, it's pretty cool. There's people walking down looking at it now, but I do keep getting interrupted. Just want to say that. However, we're going to keep going. So April 1st, 3.2 billion years ago, we have the formation of the first known continents and tectonic activity. This is a date that I added to the calendar myself, geological event. This was day 260, as I said, 3.2 billion years ago. It is my best friend's birthday, so that's why I chose April 15th. And it's the first large continent formed as smaller land masses came together. They reshaped the Earth's surface. It's very important. This event set the stage for the future life on land, influenced Earth's climate, and changed ocean events. And I said, like all these things coming together, it's like a puzzle coming together from all these different pieces, but somehow they all fit, and it forms this beautiful picture, like it's forming our beautiful. All right, now we are in May. The beginning of May on the calendar is day 248. 3,090 million years ago, which we're almost at 3,000 million years old of Earth. This is how far we've come. It's kind of hard to see because they're really small, but this is how far we come. This is how far we have. We're almost about halfway, I would say. May only contains one event, so we're gonna go to May 8th. This is the oldest record of Earth's magnetic field, 3,000 million years ago on May 8th. There we go. Next, since it was only one event, we can really hop down to June quickly. June 1st is the first eukaryote 27 million years ago with a single cell nucleus. This is pretty cool. Again, it's pink because it's a form of life that we see on Earth. Pretty cool. Next, we're hopping to June 9th. day 206, and we are hopping on down to June 17th, 2,500 million years ago. This is when the atmospheric oxygen on Earth grew to 1 to 2%. It isn't much, but it will get higher, making room for more diverse life forms as humans ourselves. Moving on, 200 days, less than 200 days on the calendar. June 25th, oldest evidence of snowball Earth. This is when Earth was completely covered in ice, which is really cool. Yeah, there's quite a commotion down by my other ones. Where are we now? All right, July 1st, day 184 on the calendar, 2,325 million years ago. That's date July 1st. However, there were no events in July, so we can just move down to August 1st, day 138, 1,930 million years ago, only containing a few events. But the next cosmic event is my own choosing, taking place on August 15th, which is my sister's birthday, younger sister. She's 16. This was 1,700 million years ago. Formation of the supercontinent Columbia, and I said the supercontinent Columbia formed as smaller landmasses collided, reshaping Earth's surface and setting the stage for other supercontinents. Right. Moving on, we have August 27th, which marks Earth as 3 billion years old, 1,600 million years ago. It's day 127 on the calendar. We're super close to the last 4 months of the year, occurring only over 1,000 million years, which we started at 46 million, or 4,600 million. So we made it this far. We have about this far to go. Again, there's people down there, so yeah, now we can move into October and September because there's not much events going on there. However, I do want to know another prompt that we had to answer. What about the 3 billion year old exoplanet? What kind of life would live on there? And since we're at 3 billion years old on August 27th, I put it in there. And I said possibly more complex single-celled or early multicellular life. All right, moving on. September 1st marks day 122 on the calendar with 1,535 million years ago. October 1st again marked day 92 on our calendar, 1,160 million years ago. Right here I wanted to add, when did multicellular life emerge? I said about 900 million years ago on October 2nd on the cosmic calendar, which is another life thing I get to point out. Multicellular life emerges, which was 900 million years ago. Sorry, it's really windy. October 22nd. So that's another event. Moving on, we jump down to, where are we? Oh yeah, another prompt that I needed to answer. Jumping down 900 million years ago, day 71, emergence of multicellular life, which was that one down there, October. And that's an event I will cover right now. Again, I'm a medicine major, so if life forms like multicellular weren't emerging, I wouldn't be here. It's what I'm studying right now, how the human body works. So I find it really fascinating that's what we started from 900 million years ago to what I'm studying today. I'm studying how the muscles work and everything, so I wanted to point it out again. Multicellular life began, allowing for more complex organisms to form. This event laid the foundation for plants, animals, and fungi. And my analogy was that with more forms of life getting more complex, there's just more moving parts. Multicellular organisms can be created like humans are today. And I said that's much like Legos. It's like you have pieces, a lot of small pieces, they all come together and something great forms, and it's pretty cool. So that's my analogy. The last 2 months are on November and December, last 2 months of the calendar year. November 1st, 775 million years ago, day 61 on our cosmic calendar. And as I mentioned above, there's oldest evidence of snowball Earth, and now we have past the last of the ice fully covered in Earth. So most recent snowball Earth, 650 million years ago on November 10th on our cosmic calendar. And here's my thing for that. So like I said, November 10th. Moving on to a month and a half-ish of the year. November 19th, the Cambrian explosion of life, 542 million years ago. This is day 43 on the cosmic calendar, so we're less than 50 days on the calendar. Here's this guy, Cambrian explosion of life. A lot of life went extinct, but we're still here today as humans, so. All right, a few days later, we have have November 24th, 480 million years ago. The first fish on my calendar, that's only day 38. So we have 38 to 1 and 0 days, a month left in the year, about. And this is how far we've come. This is how far we have to go. Yeah, we've gone a long way, the calendar year. And this first fish happens just a few days after. So how many days is that? 5 days after this first Cambrian explosion of life, when a bunch of life forms came up. And I think I said extinction on accident earlier, but it is not. It's all these life forms popped up. Next, November 27th, 3 days after, we do have an extinction. So the first fish, and then next we have the end Ordovician mass extinction, 85% of. Okay, continuing. The next event was on day 33, November 29th. On November 29th, arthropods are now on land. You can see that right here, 420 million years ago. All right, November 30th, we're on the last day of November in the home stretch of the calendar year. We have the atmospheric oxygen nearing present levels. This is 40 million years ago. This is day 32 on our cosmic calendar. All right, December 1st, we have home stretch, 300 million years, but it's only 1 month or 31 days. And it contains the greatest amount of events, because all of these events in the last bit of the calendar year happen, and as time progresses, more things change, more things happen rapidly. The first of the month, December 31st, is day 31, so we're going from 31 to 0, 385 million years ago. Here we have December 2nd, late Donovan mass extinction. 75% of all species were wiped 375 million years ago, and that's how far we've come. We have a little bit left, just the home stretch here. And then on that very same day, as this extinction, we have vertebrates are on land now. And it's kind of funny looking at it because it's only 375 million years ago, but it's in the span of this 1 million years. So it's not literally on the same exact day extinct, but also these popped up. It's just in 1 million years. So we have the vertebrates on the land 375 million years ago, December 2nd. Next, we have the first seed plants, December 3rd, day 29, 360 million years ago. First seed plants made their way into existence, which is pretty cool. Yeah, here's that. Again, we have all these life forms popping up, and an extinction happens right after. So we have December 10th, 280 million years ago. We have the supercontinent Pangaea right here. And then a little bit after Pangaea, like I said, an extinction happens. So we have the end Permian mass extinction, December 12th, 250 million years ago. This is day 20 of our cosmic calendar, and nearly 95% of our species were wiped. So here's that. Alrighty, next we have first dinosaurs and mammals. Mammals, 220 million years ago, December 15th. This is one of the events from the Excel graph that I'm going to be talking about. I think dinosaurs are super cool, and mammals, so there was nothing super specific about it. I thought it was cool. Animals, dinosaurs, and I've never seen a skeleton in person of a dinosaur, but I wanted to talk about it anyway. The earliest mammals and dinosaurs appeared, marking about the cutoff again. I thought that was pretty cool. I was saying that it was an evolutional history moment. The event is a key transition towards the diverse life forms that would dominate Earth for millions of years. The mammals and dinosaurs are the calm before the storm of extinction. That was my analogy. It's it's calm, it's nice, and then the storm hits, the extinction hits, and these animals are just chilling, and then they're gone, pretty much. December 16th, 200 million years ago, two events occurred. The end Jurassic mass extinction and the supercontinent Pangaea breaks up. Both these December 16th, 200 million years ago. So here are my markers for that. This is kind of, again, windy, but wow, we've come a really long way, almost at the very edge of the mall, and we just have a few more days left. What causes extinction was huge volcanic eruptions, and that was probably caused by the continent breaking up. There's just a lot of movement of the plates and things like that. Keep going. December 22nd, earliest flowering plants, 130 million years ago. and this was only 10 days left in the year, so we were getting pretty close to when humans start coming around. Okay, the next event we have is the end Cretaceous mass extinction. 75% of species were completely wiped 65 million years ago, December 26, 6:18 p.m. And now we are at the markers of timestamps. So we're gonna have timestamps, I'm pretty sure from here on out, 6:18 p.m. specifically, getting really close to the humans. And this was on day 5, so 5 to 0, we're almost there. The next event I have is December 27th, 60 million years ago at 5:55 a.m. Early primates and the formation of the Amazon rainforest, which I actually have right next to it, even though it is the same day. I just spaced it a little bit apart because the time is different. This is day number 4 on a calendar, and the formation of the Amazon rainforest is something that I just wanted to add into this. And I thought it was one of the most notable greeneries in the world, and all the species and biodiversity adds richness to this region. And my analogy is like a small vegetable garden. It began to take shape, providing a rich and diverse ecosystem that would support a vast range of plant and animal life. This event is crucial in understanding the development of Earth's ecosystems and biodiversity. So, again, I added this one. It's blue because it's something that I added. Next, we are finally at December 31st. The rest of the events are December 31st throughout the entire day. The Grand Canyon formed 6 million years ago, 12:34 p.m. And then, from here on out, it's just going to be 6 events combined into one day, but at different times throughout the day, even though it was over still the millions of years. Let's see. Okay, here we go. On this same day, first hominids, 5.2 million years ago, December 31st, 2:05 p.m. And one of the prompts that we had to answer was how many days passed between the extinction of dinosaurs and the emergence of modern humans. I said about 5 days on the cosmic calendar because we had them at, I believe, the 26th. We go to the 31st. It's only 5 days between humans and dinosaurs, when in reality it's millions of years, but in this case it's only 5 days. And then again, I want to talk about another prompt. How many minutes before midnight did modern humans emerge? We have roughly 18 minutes before midnight on December 31st, as we go to the modern Homo sapiens emergence 150,000 years ago. So we're less than a million years, December 31st, 42:52 p.m. Welcome back to the rest of my cosmic calendar. I am now in my dorm hallway, but I might have just 3 more events, and all of those happen within minutes of each other on my cosmic calendar. So they're only, according to my Excel graph, they're only a few centimeters apart, so it actually kind of works out. Unfortunately, there was a basketball game that I wasn't aware of when I was filming, so cars were coming in the area that I set up my calendar, but for the most part I was able to finish it. I do have a video of me showing the entire span, so I'm going to add that, but this is the last 3 events of my cosmic calendar. But again, there's nothing I can do about the just the interference with the people in the cars and everything like that, but I am finishing it up. So without further ado, I'm going to talk about the last 3 events that I have here. So humans nearly go extinct 75,000 years ago on December 31st at a very specific time of 11:51:26 p.m. and only a few hundred pairs survive. So we're basically right on the cusp of the present, 9 minutes before the present. And then about 50-ish thousand years later, we have the first domestication of dogs on December 31st, and I would say this is about 11:54 p.m. So just a few minutes before midnight, first domestication of dogs. This is an event that I added to the cosmic calendar by choice, and I added it because I love animals. I have a dog at home who I will be seeing when I go home for spring break, and dogs and all pets really are man's best friends. So I just wanted to emphasize this event is so many people have dogs just across the world. They are really great companions. So this marks the start of one of the most significant human-animal relationships in history. This event changed both human and canine evolution, creating a bond that lasts through the ages. That's that. And my very last cosmic calendar event is Greek ancient astronomers
2,000 years ago, which would be December 31st, 11:59:46 p.m. And there wasn't a picture for this event, even though it was on the Excel spreadsheet, so I just added like cosmos, stars, and the moon because the ancient Greek astronomers paved the way for what we know now. And they began making discoveries and started viewing the sky and everything that there is with it. So this is from the Excel spreadsheet, as I just said, but it's something that I wanted to cover because I've been using a telescope for my from the astronomy department for my honors project for the Alien Earths course. I've been looking at the moon, Jupiter, and its moons, and other cosmic objects that are visible, including I've seen some constellations, maybe even Saturn, Venus. I've compared my images of the moon to Galileo's images of the moon when they were first using telescopes and were able to see, making just a ton of discoveries. So this event that happened, which is my last event and most recent event, I really just wanted to talk about it because it's honestly just become really personal to me, like what I've seen with the telescope, and they made groundbreaking discoveries that helped shape our understanding of the cosmos today. It marked a pivotal moment in the history of science, laying the foundation for modern astronomy and science as a whole. And my analogy for this event was like a candle in a dark room. The ancient Greek astronomers illuminated our understanding of the cosmos. Although this cosmic calendar breaks down the billions of years into only 42 events and 365 days, they all had an immense impact on our planet now and took place over millions upon millions of years. Thank you for following me on this journey through the history of our world in only 1 year.
Hello, this is the end of my cosmic calendar. I am in my room, in my dorm room now. It started to get really busy when I was filming, so I figured I will just finish it up over there and come back over here. There's a basketball game, unfortunately, and I didn't know that, so I just kept filming until too many cars were there, and I'm here, but I do want to finish this without the distraction, just end my cosmic calendar. So the last two prompts that we needed to answer, I'm gonna read it off, and then I also wrote down my answer just so I don't forget anything. All right, so number 8, that prompt. Suppose that scientists announce the discovery of an Earth-like planet orbiting 1 AU from a sun-like star. Astronomers have determined that that planet is 1 billion years old. If life emerged and evolved on this planet in a manner identical to how life evolved on Earth, then go back to your cosmic calendar to explain what kind of life we can expect to see on this new planet. So this is 1 billion years ago. And so I said, if scientists discover an Earth-like planet orbiting 1 AU from a sun-like star and determine it's 1 billion years old, we can use my cosmic calendar to predict the kind of life that would happen. So 1 billion years ago would be March 21st, according to my cosmic calendar. At this stage in Earth's history, life was still single-celled, and the only organisms present were prokaryotic microbes, similar to bacteria and archaea. No complex cells, multicellular organisms, or oxygen-rich atmospheres. If life evolves similarly on this planet, we would expect to find the biosphere dominated by microbial, possibly in oceans or hydrothermal vents, much like early Earth. So that's my response for the first prompt. And then number 9, that last prompt that we had to answer. Same situation as the previous question, but now assume astronomers made a mistake when calculating the planet's age. One of their students corrects the mistake and finds that the planet is actually 3 billion years old. So much closer, or much further down in my cosmic calendar. If life emerged and evolved on this planet in a manner identical to how Earth evolved, much more recent in my cosmic calendar, but still a long time ago, but it's 3 billion years old as opposed to 1 billion. I'm sorry, I just wanted to preface that, or correct that. Okay, so now if the planet is actually 3 billion years old, this corresponds to August 27th on the cosmic calendar. So that's the billion-year marker, August 27th. At this stage on Earth, eukaryotic cells with a nucleus had not appeared yet, but microbial life was flourishing. Photosynthetic bacteria like cyanobacteria was beginning to produce oxygen through the atmosphere, and it hasn't reached modern levels of oxygen in the atmosphere, but we are getting there. If this planet follows Earth's pattern, it might have extensive microbial life with some primitive photosynthesis occurring again at this time of 3 billion years ago. However, multicellular life would not have yet evolved, so the planet's ecosystems will be microscopic with bacteria and archaea as dominant life forms. And I just wrote everything down, so that concludes my cosmic calendar project. Again, this was a recreation of Carl Sagan's cosmic calendar that he made, and I walked you through the calendar years January 1st through December 31st, and on that very 31st day so many events happened. Even though it was the one day of the cosmic calendar, it was such a long time spread out, but sometimes our brain can't even comprehend how long that was. So exactly December 31st, it was from 6 billion years ago to literally 20 minutes ago. But yeah, I really enjoyed this project. There was a ton of moving parts to it, but it was really fascinating to see all of these moving parts and how it is created Earth as we know it today.